So first, we've seen that in the blood levels, we see if there's low omega-3, EPA and DHA, and low arachidonic acid in kids who have are autistic or on the spectrum, and there's compared to quote normal normal divergent. There's neurodivergent and there's the other term, whatever. So there is evidence that having low levels of all of these fatty acids is associated with having autism. And then there also has been work done by Vanderwolf, and she has put together studies looking at kids who are a little older and interventions with them directly and not during pregnancy. And she's found that about an omega-3 index of 6% is kind of the target where you start to see, once you get kids to that 6%, that's usually where you start to see some improvements. Yeah. And that also kind of equated to about 450 milligrams of EPA and DHA a day.
Which makes sense.
Yeah.
Which makes sense. Yeah.
And for kids, it's typically their omega-3 levels are lower than adults. It seems like there's definitely association with age. Yeah. So for the adults, we've tried to target 8%. For kids, 6% is a good first level target.
That's great. And could you talk about the actual testing method that you developed?
Yeah. And so this has been we do a filter paper blood spot test, which is becoming very common these days. This has been done with fatty acid research for decades. So this is nothing new to the research community. And so we at OmegaQuant have... we do a finger stick test, so you can get it at home, get a little kit.
Meaning you can do it yourself.
You can do it to yourself. Yeah. It's a lancet. Yeah. If you are a child, you might want to, as far as our lancets go, they're a little bit bigger. So if you're a kid, you might want to get a smaller lancet so it doesn't hurt as much. But
from your local CVS?
From a CVS or from Amazon. And then you just prick your finger. You do a blood spot onto the filter paper, send it into our lab, and we work in Sioux Falls, South Dakota, and we analyze the fatty acids that are in that blood spot. And with the omega-3s, we're able to see a very, very clear signal with the level in the blood spot and then also intake. So it's really great.
So to sort of bring this down to the cellular level, if folks at home can imagine looking under a microscope at bunch of red blood cells and then zooming even further, you're looking at the membrane, right, of the red blood cell, and you want to see that membrane has at least 6% formation. If we're talking about the formation of the membrane, 6% of that should be omega-3 fatty acids, EPA and DHA. What does that mean? I mean, what does it mean for how the cells are working, how that's going to translate to the health and benefit of the child?
Yes. Such a great question. So the blood has plasma and it has red cells. Half of the blood is red cells and half is plasma, but almost everything you measure at the doctor is in plasma. Looking at red cells is actually kind of boring to most people. So we actually like looking at the red cells. It is, they carry oxygen all over the body, super important. But they're really just tiny little cells that have almost nothing but the phospholipid membrane. And so that lipid membrane, those are where the fatty acids are. They create the kind of the wall of the cell to the membrane of the cell. And they're all different kinds of fatty acids. They're saturated, monounsaturated, poly. They're all different kinds. And so we measure all of them. We measure 24 different kinds of fatty acids. And like you said, we can see the percent of them that are EPA and DHA or total omega-3. And we're able to, those types of fatty acids are interesting because they're of an interesting shape. They make space in the cell. We think there's a level of flexibility it gives the cell, but it certainly helps, and fluidity. So it helps, the body makes that, picks out the right types of fatty acids to make those membranes so the red cell can function. And so it's more like a tissue level. We've seen when in rat studies, we don't do this in people as much, but the level of omega-3s in the red cell is reflective of the level in heart tissue, muscle tissue, pretty much all tissues except for the brain. Unfortunately, the brain is much, much richer than red cells in omega-3s. So that does not correlate as well, but you still, if you have more omega-3 in your red cells, it's going to be in your tissues, and that's where it's going to have its effect. Sure. And then if we went into the inflammation topic, that's where omega-3s are actually pulled from the membrane in an inflammatory event to create all these molecules that affect how the body responds to inflammation.
Inflammation. Medical buzz term of the day for a really good reason. That's a whole other episode for which you'll end up coming back and telling us all about. It's really easy for folks to interpret, though, right? I mean, this is an example of your report. And you mentioned this earlier, this percentage number here, and this being, 6.10 as per example. And then even to your point, Dr. Murray, where you're talking about, okay, here's just enough, to get by and get the body, but optimal levels. Let's have that conversation. How we're looking at this index here, and also what optimal percentage we should all be striving for.
Yes. So the omega-3 index was originally created around cardiovascular health in adults. And they found that an 8% omega-3 index is those are the people who have the fewest amount of heart attacks and sudden cardiac events.
Of which, by the way, 50% are silent, right? And not measurable, predictable, at least through symptoms and or even cholesterol levels. So when you have an 80%, and this is, by the way, stuff I learned from your dad.
Oh yeah, this is
through
his
your
baby.
research, getting up to that 8% or higher, and this is for the adult cohort perhaps, but you're actually reducing your chances of heart attack, silent and otherwise, by 80%, maybe some of the literature supports. That's amazing.
Yes. So that's the original audience for this test, and less than 4% was the lowest group, highest risk. And when we started to look at the pregnancy area, kids, those are different areas. So we were trying to look at a completely different set of research, and we found that, and others have found that for kids, kind of shooting for 6%, because kids tend to start at like 2%. We rarely see an adult at 2%, but kids could be lower. So don't be worried about that, I would say. But looking to try to get to 6%, being at 8% would be fantastic for kids. We don't see any issues with that. And I will say, I believe it was the government in Norway was trying to find the upper limit of intake for children for omega-3s, and they weren't able to find enough evidence to even set an upper limit. It doesn't mean you just bathed in omega-3s all the time, but it does mean it's a very safe thing to have and to give to your kids as well.
And based on, if a parent does this test, sees what their child or their own number is, how often would you recommend retesting after supplementing to start seeing results?
Yes, the best thing to do would be to take a test before you start supplementing to see
where your baseline
level is, and it does affect how much are you getting from your diet already. Are you eating fish? Then you'll have some in your body. We would recommend retesting after 3 to 4 months. That's about the life cycle of a red cell, of the red cells in your body, and it helps. You're kind of maybe at the steady state for the supplementation or intake dose that you're at there. And then you can, if it's not as high as you want, then you can look at increasing your dose. But there are other things that do affect your absorption. So your product, the supplement you're using, could have a form of omega-3s that you're not absorbing well. If you don't take it with a meal, if some people can take it without a meal and absorb it fine, some people need that extra ability to absorb fat to really get everything out of the supplements, or the form of the supplement could really matter.
I actually want to talk about that because of the science behind this guy in a second here. Confirmed research actually using your test model. So we'll talk about that in a moment. But just to go back for parents for a second, the testing that you offer for the mother's milk, I mean, that's the one we're seeing here on the screen on the left here. So the child is, breastfeeding, and you don't want to lancet them. And you also want to know, and again, you're not necessarily going to be supplementing them, and maybe they're low because you can't introduce fish at an early age. This is a perfect option to be able to test your mother's milk. And then, of course, it's on to mom now, right? What does she do to intervene? So this is another baseline, bookmark, intervention, and then retesting. What if a mom finds herself low? Well, both of you, I'd love to hear from you. What are you telling moms to do?
500 milligrams, start with 500 milligrams DHA, molecular distilled, so there's no impurities, no mercury, no pesticides, anything else. Start taking 500 milligrams every morning after breakfast. And then 3 months, retest.
And what's great about the milk, mother's milk, is that it changes much faster than the red cell. So they could test in a couple weeks, really. What's also nice is you don't have to prick yourself. It's just taking a sample from a bottle or from yourself. Because we're doing a percent composition, the amount of fat in the breast milk, which changes dramatically throughout a feed and throughout the day, that doesn't affect the number that we're getting. So it's very robust in that way. And you're able to, if you did, you don't breastfeed for that long. So waiting 3 months might be too long, but you could test within a month, and then see where you're at. And this is more like plasma compared to the red cell, where what you absorb it's amazing. We've done some research, and whatever mom is taking in with DHA, especially if she doesn't have a very good level herself, it's going right to breast milk.
Right.
It is just showing how important it is.
Nature's priority.
To the baby, yes. It's wild.
And then there's this other wonderful test. I love you guys have developed these, the prenatal DHA. So, okay, we've got the breast milk. We can test for that, and we can intervene. We've got a child now who's a couple of years old, maybe just before they're weaning off and they're starting to introduce diet. We can test their blood. But this intermediate marker, now the child's in utero, we can test mom's blood. Why? Not just for mom, but also because this is the blood that's serving the infant or the unborn infant, the unborn child, which is amazing.